Hello everyone, my name is Nur Nawara Wadiha and today I'll be presenting about differentiation. Let's jump to the question number 1. Explain the meaning of differentiation and what are the techniques of differentiation. As we know, differentiation is a way to find how fast something is changing. On the other hand, differentiation is a method in calculus that used to find the rate at which a quantity changes. In simple terms, it helps you find the slope of a curve at any point. Super simple example, imagine if you are riding a bike and if someone asks you, how fast are you going right now? That's what differentiation will tell you. In math, if you have a function like y equals to x to the power of 2, differentiation will find how fast y is changing as x changes. The derivative of y equals to x to the power of 2 is 2x, which tells you the speed of change at any point. So the conclusion is, function is what something is doing and derivatives is how fast it's doing it. Let's see how to differentiate function using the technique of differentiation. For instance, if we are given the function of 2, how to differentiate the function? As we know, 2 is a constant because there are no variable beside the number, so the derivative will be 0. And if we are given 2x to the power of 2 plus 4x, the derivative will be 4x plus 4. How can you do it? You can do it by bring the power down and subtract 1 from it. So the final answer will be 4x plus 4. Here are the other technique of differentiation, which is quotient rule. We can substitute the function given into the formula, which is v prime minus uv prime divided by v squared. The numerator will be u and the denominator will be v. U prime is the derivative of u and v prime is the derivative of v. And this is what we will use when we are dealing with the trigonometric or exponential and logarithmic function. For instance, we have sin x, so the derivative of sin x will be cos x. And this is the chain rule. We usually use the chain rule when we are dealing with polynomial function.
Okay, next for question 2 part A, given y equal to 3x squared secant x plus 2. This is a product of two functions, which is u equal to 3x squared, v equal to secant x plus 2. To solve this question, we need to use the product rule, which is dy per dx equal to vu prime plus uv prime. Then we need to differentiate each part to know u prime and v prime. U prime is equal to 6x and v prime is equal to secant x plus 2 tan x plus 2. Now apply the rule in the formula, which is dy per dx equal to secant x plus 2 6x plus 3x squared secant x plus 2 tan x plus 2. So the final answer is dy per dx equal to 6x secant x plus 2 plus 3x squared secant x plus 2 tan x plus 2. Next for part B, given y equal to 4x plus 2 divided by cos x. This is a quotient of two functions, which is u is equal to 4x plus 2 while v is cos x. To solve this question, we need to use the quotient rule, which is dy per dx equal to vu prime minus uv prime divided by v square. Then we need to differentiate each part to know u prime and v prime. U prime is 4 while v prime is negative sin x. Now plug into the formula dy per dx equal to cos x 4 minus 4x plus 2 negative sin x divided by cos x square. Now simplify the numerator and the final answer is dy per dx equal to 4 cos x plus 4x plus 2 sin x divided by cos x square.
Hello, it's me Nur Nawara Wadiha and I'll be explaining about how to find the derivative of y with respect to x by using implicit differentiation. First, why do we use implicit differentiation? We use implicit differentiation because this equation involves both x and y. That means we will differentiate both sides of the equation with respect to x by treating y as a function of x. First, we need to separate the equation into three parts, which is the first part is y ln 3x, The second, exponential 2x plus 1. And the third is 4 times 4y. Let's go to the first part. The first part is we need to differentiate y ln 3x. Since this is a product of two functions, we will use the product rule by substitute the function given into the formula, which is vu prime plus ub prime. But remember this, every time you differentiate a term with y, we will multiply with dy over dx. So let's see. The u is y and the u prime is 1 multiplied with dy over dx. Same goes to the v. The v is ln 3x. We know if we differentiate ln, we will get 1 over x. But in this case, we have ln 3x. So the derivative of ln 3x will be 1 over 3x. But we need to differentiate the power inside too, which is 3x. If we differentiate tx, we will get 3. So the final answer will be dy over dx multiplied with ln 3x plus y over x. The next step is we need to differentiate exponential 2x plus 1 by using chain rule. As we know, if we differentiate exponential, we will get back exponential. Same goes to this case. We will get back exponential 2x plus 1. But in this case, we need to differentiate the power 2, which is 2x plus 1. If we differentiate 2x plus 1, we will get 2 plus 0. So the final answer will be 2 exponential 2x plus 1. And the next step is we need to differentiate tan for y by using chain rule too. As we know, the derivative for tan is second, so we will write down second for y. So whenever you differentiate a y, you will use a chain rule and multiply by a dy over dx. That's what we apply to 4y. And the next step is we need to plug all into an equation. Bring the equation with dy over dx into one side, separate both of them by factorizing dy over dx. And lastly, solve for dy over dx.
Okay, so for the question 4, by using linear approximation to estimate the value of fourth root 80.99 minus with 2 over square root 80.99. For the first step, let the function of x equals to fourth root x minus 2 over square root x. So we change it to a simpler equation. So x equals to x is a power of 1 over 4 minus with 2x power of negative 1 over 2. So we differentiate it into 1 over 4 x the power of negative 3 over 4 plus with x the power of negative 3 over 2. And then x, for the second step, x, we assume x the given value, which is 80.99, and x 0 equals to the, which is a chosen value. So the nearest number from 80.99 is 81. So we take 81 as a chosen value, and then the delta x, we need to minus x with the x0, which is 80.99. We need to minus with 81. So the result is negative 0.01. And then by using the formula function of x0 plus delta x equals to function of x0 plus function that has been differentiated equals function of x0 times with delta x. So we substitute the value we have, and then we will have the final answer, which is 2.778. That's all for me.